I thought this was an interesting question that appeared on a Calculus 3 midterm exam. This was a problem given at UCI. So let's go over this one and let's do it together. This guy says find the average value of the function f of x, y, z equals 7, x squared plus y squared plus z squared squared over to solid E. E is the region between the two surfaces x squared plus y squared plus z squared is a squared, and x squared plus y squared plus z squared equals b squared. B is greater than a. Okay, so in this course, they did not learn how to find the average value of a three-dimensional function. Okay, and I didn't write it here, but the professor in the exam said that if you don't know how to find the average value, just find the triple integral of this function over E and you'll get 70% of the credit. Okay, so that's what they learned in the class. But this is trying to test if you can apply triple integrals in a new situation that you actually learned before. You just have to extrapolate the idea from 1D to 3D. So this is probably one of those questions that helps differentiate who gets the A's because they can make that connection versus who gets the B's because they might be able to B or C grade because they might be just able to find the triple integral over E and get 70% of the credit, okay? So let's think about how to do this. Think back to Calculus 1, single variable calculus. How did you find the average value of a one-dimensional function? Okay, it was 1 over b minus a integral a to b f of x dx. This is how you found the average value of f over the interval a and b, a to b. Okay, so interpret this as you're summing up all the values of f in between a to b divided by the length of that interval. Okay, that's how I encourage my students to remember it. Because that's what, when you average numbers, you add them up and divide by number of terms. This is very similar. You add it up, divide by the length of the interval. Okay, so when it's three-dimensional, we can probably make a very educated guess that we're going to have to triple integrate over the region, okay, and divide it by, instead of a one-dimensional length, what's an equivalent in, not equivalent, but what's similar in 3D? It's volume of the region E. So we're going to integrate, we're going to sum up basically all the values of f over this surface E and divide it by the volume of E. See how these are kind of analogous? Okay, so this is how we're going to approach it. So you need to be a critical thinker in order to get that extra 30%. And so that you don't just get the 70% by doing a procedural thing. This is the new stuff that you have to learn to apply to. Okay, so let's first find the volume of E. Let's figure out what this E is. Well, this is a sphere, radius A. This is another sphere, radius B. So let's just do a quick sketch. Technically, the professor asked to sketch the region as well, so let's do it. Okay, so we have B is greater than A, right? Did I say that this one's bigger than this one? I don't remember already. So let's draw two spheres. This has radius, let's say B, okay? And then another sphere with radius A. Yeah, so this in between is the region, E. So what's the volume of this in between? It's just volume of the big sphere minus volume of the smallest sphere, yeah? So volume of E is, what's the equation for the volume of the sphere? It's 4/3 pi r cubed, where r, the outer one is b, so b cubed minus 4/3 pi a cubed, which we can factor. 4/3 pi b cubed minus a cubed. Okay, so we got this part. Now we got to evaluate this triple integral. Okay, so we have our surface over here, our surface region, whatever you want to call it, E over here. So how can we get limits of integration? Well, we probably want to use spherical coordinates to make our lives easier, okay? So spherical coordinates, okay? So it will be a rho, it will be a theta, and it will be a phi or phi, whatever you want to call it. I say both. So excuse me if I switch back and forth between phi and phi, okay? So what does rho have to swing from and to? It's the minimum value of rho is A. Rho is like radially outward, yeah? So minimum value is A, and the maximum value is B. So from A to B, okay? Now, what about theta? Theta is the angle from the positive z to the negative z, or the north pole to the south pole. That's how I was taught it. So it covers the whole area, north to south, right? So it'll be 0 to pi. Sorry, that's theta, so 0 to pi for phi over here, okay? Theta is the angle over here. It swings a whole 0 to 2 pi in the xy plane, right? So 0 to 2 pi. Okay, so we can set up our triple integral now. So integral from 0 to 2 pi, integral from 0 to pi, integral from A to B, okay? What is our function? Let's change this guy in terms of rho, theta, and phi as well. So this is just 7 rho squared squared. So 7 rho to the fourth. 7 rho to the fourth. And then when we have spherical coordinates, it's not just d rho, d theta, d phi, right? It is rho squared sine phi d, let's match my order, d rho, d phi, d theta. That's how we set up our triple integral, yeah? Okay, so since everything's being multiplied, and these are all constants over here, let's split this up into integral from 0 to 2 pi d theta times integral from 0 to pi. We have sine phi d phi, and then times integral from A to B. We have rho to the 6, right? 7 rho to the 6, I'll say. Because there's a 7 there, I'm going to forget it. So let's put it there. 7 rho to the 6 d rho. Yeah? Okay, so this integral is just 2 pi, okay? Because it's theta, evaluate from 0 to 2 pi, so 2 pi minus 0, which is 2 pi, yeah? And then this guy would be minus cosine pi plus cosine 0, okay? And then this one would just be rho to the 7th over 7 times the 7, so it's rho to the 7th, evaluate from A to B, so it's just rho is B, so B to the 7th minus A to the 7th. Okay, so then this is, cosine of pi is -1 times another negative, so that's +1, this is 1, so it'll be 4 pi B to the 7th minus A to the 7th. Okay, so we got this triple integral now, we have both pieces. So this, I'll say average equals this, which is the triple integral we found on top. It's 4 pi B to the 7th minus A to the 7th over the volume of E, which we have over here. So 4 over 3 pi B cubed minus A cubed, yeah? And this simplifies to, so it's 3 on top, so it'll be 3 B to the 7th minus A to the 7th over B cubed minus A cubed. And that's our answer. Okay, so it's not too bad. It's a little tedious in some cases, but again, the idea is if you never learned how to find the average value for a 3-dimensional function, think back to how you learned it in single variable calculus, in calculus 1, a 1-dimensional function, and then just extrapolate that idea into 3 dimensions. That's what you have to do a lot of times when you get into the vector calculus portion. You learn it in 2D and then you extrapolate to 3D very similarly. Okay, hopefully this was helpful. If you are practicing for a midterm or final exam for calculus 3, it's just a different type of problem that I saw that's not typical. So hopefully this is useful to see a new type of problem.